intention for us out of this session is generating interest rate trees, and what are the ways in which the various models are available to handle this. So wherein probably on a broader scale, if I have to look at, we are considering a simple model which is called as a term structure model with no drift. This is one which we will look at. Similarly, we will talk about term structure model with the drift, or probably with constant drift. We will talk about these things. Then we have a third set of interest rate generating model called as Holy model. We will talk about this model also. And finally, we would also look at a slightly more sophisticated kind of interest rate generation model called as the Vamsidhar model. So these four models primarily is our focus in this session. We will try to build the interest rate trees under the assumptions of each of these four models. Alright, so let's get started into that. The first of them is focusing on generating a term structure model without any drift. Now in this model, the way we are talking about generating the interest rates from period to period follows this kind of an equation. A small change in the interest rate within a small time period dt, the rate of change of the interest within a small period dt, it is assumed to be equivalent to the annual volatility of the interest rates multiplied by a normally distributed random variable. So which means here the interest rates are assumed to follow a normal distribution, right? And it's also assumed that if the annual volatility is something. So let me take some example here. Let's say if I consider a situation where annual volatility is probably 100%, or probably 100 basis points, which is 1%. So the annual volatility, let's say it is 100 basis points, and probably if I want to model the short-term interest rates, I want to model the short-term interest rates on a monthly basis. So for this, first I need to know the sigma. As far as this model is concerned, the sigma is 100 basis points or probably 1%, right? Once I am talking about 100 basis points, I can take that the sigma is 1%. Now this is an annual value. So if I am looking at the monthly value, I have to adjust it by multiplying it with square root of dt. So if I am talking about monthly, so dt for me is nothing but 1 by 12. So dt is going to be that much. And what we are saying, dw is a normally distributed random variable. So what do I mean by that? For dw, the mean is 0 and the standard deviation is square root of dt. So what is the standard deviation here? Square root of dt. So the dw for me is a normally distributed random variable. Now what does that mean? I can generate some random value. How do I generate that random value here? Probably if I am saying the norm S inverse or probably norm S distribution, standard normal distribution, or it need not be a standard because we are talking of mean equal to 0 and variance is not equal to 1. So I'll directly go with normal distribution, norm inverse, wherein if I want to generate for some random probability based on the mean and the standard deviation, I'll get some random value. So probably in this case, let's say I've got the dW as minus 0.17. We can get any number, right? Because it is following a normal distribution with mean equal to 0 and the standard deviation equal to square root of dt. So if I'm looking at refreshing it, I'll get different sets of values, right? Sometimes plus, sometimes minus, whatever it is. So what does that mean? The dW is going to be something like is going to be this value, because it will generate a set of random variables with a mean equal to 0 and standard deviation equal to mean. So if I am assuming that this is the value, well, how do I come out with my interest rate? Let's say currently the short term rate, let's say it's around 5%. How do I use this information now? I will take dr. dr is nothing but the annual volatility times dW. So the annual volatility is 1% times this is my dW. So this is what is going to be my dr, right? So probably I can very well say that the interest rates for the next month, is going to be this much plus this much. So probably if I am extending it in terms of the percentage and probably the decimal points, it is coming out that the next period interest rate is going to be 5.1. Similarly, I can very well generate 5.58, 5.07, 5.53, 5.06, 4.95. So there could be a decrease or there could be a increase kind of situations. So this is how we generate the interest rates for the next periods using the no drift model. What is this no drift? We are not increasing. Let's say the interest rate currently is 5%. What is happening here? 5%. The next period interest rate, how are we computing? 5% plus sigma times dW. And because dW is a random variable that has a mean of 0, what could happen is, on an average the increment is 0. So 5%, if I am taking the mean of this entire thing, it is still 5% only, because the mean of dW is 0. So there is no constant increase or constant decrease in the interest rate. The interest rate is always fluctuating around that 5% mark only. In some cases it may go up, some months it may go down, but on an average it will be around the 5% mark only, because the dW is a normally distributed random variable with 0 as the mean. So obviously for this entire thing the mean will come out as 0. For the change in the interest rate, the mean will come out to 0, which means the interest rate will fluctuate around that 5% only forever. Means there is no constant growth or constant fall in the interest rate at all. That is the reason we call it as a no drift kind of a model. And how do I use this model to build the binomial tree of the interest rate? So if I am assuming